Okay, welcome. And so now we're going to introduce the theorem for the formula for taking the derivative of any log in the general case. So any log function. So in this case here it says let a be any value greater than 0. So anything positive. So then this is always going to hold true. The derivative of this log function is going to be 1 over x times the natural log of the base a. Okay. Now, this also includes the natural log, because if we have a natural log, that's log base e, right? And so if we take this, if this is log base e, then this is going to be 1 over x times the natural log of e, which is 1. So this is where we get 1 over x. So this general formula also includes the other formula when we were dealing with natural logs. So we're going to apply the same thing, but this time we have to divide by the natural log of the base. Okay? But in the specific case of the natural logs, that just turned out to be 1. Okay? So let's do an example. So in this one here, we're going to take the derivative of this. Well, let's simplify this first. So this is going to be the derivative with respect to t. And this is 2 squared, right? So this is 2 squared to the t. So this can be written as 2 squared to the t power, and then we could use the properties of exponents to multiply these. So this is 2 to the 2t. So let's write that as 2 to the 2t times 2t squared. Okay? Now, this can be further simplified by using the other property of exponents, because we've got the same base, so we can add these exponents. So that brings us to this. And so now we've got this exponential. Now, so in this exponential, what do? Well, we're going to use the general case. So remember with the exponential a to the x, right? What do? We multiply by the derivative of the inside function. Right, so we're going to multiply by the derivative of the inside function and then multiply by the derivative of the outside function, which gives us the same thing. Okay? But also, remember we have a different base, right? So in this case here, what do? We're going to end up with a natural log of 2. Okay, so we can't forget that. So here we're going to multiply by the derivative of the inside function times the derivative of the outside function, but then we also have to multiply by the derivative of the base, okay, which in this case is 2. Now if it was e to this, then we wouldn't have to worry about it, because remember, the natural log of the base, which is the natural log of e, would just be 1. So this also works for that case as well. But in this case, we have the base as 2. So in this case, the final answer is going to be the derivative of the outside, or excuse me, the inside, which is going to be 2 plus 2t times the derivative of the inside function, which just gives us the same thing, and then times the natural log of the base, 2. And that's our result. That's it. So now what about the log? Well, log, we're going to take the derivative of log. Here, we're going to end up dividing by the natural log of the base, 8. We're then going to take the derivative of the inside function and the derivative of the outside function and multiply by the derivative of the outside function. So let's do this first. We're going to take the derivative of the inside function, which in this case is 14x, right? This just goes to 0. So we get 14x. And then what we're going to do is multiply by the derivative of the outside function, which is a log, which means we're going to multiply by 1 over whatever's in here, which is 7x squared plus 4. And then we're also going to divide by the natural log of the base, which gives us 1 over natural log of 8. So the final answer then becomes what? 14x divided by the natural log of 8 times 7x squared plus 4. And that's it. So now let's give you guys one to work on. So here's a couple for you. So the first one is, of course, an exponential. So evaluate these. Oops. Okay, you guys work on those. And that's it. See you next time.